Kids. All right, this is going to be part two. So remember, we have our gas. It has internal energy. Why? Because the gas molecules are moving around. So remember, our symbol for internal energy is U, because that's the energy stored in the gas because of the gas molecules are moving around. But last time we didn't do any work, so we locked our piston in place. This time we're going to do some work. So let's say the first example is literally something pushes down on the piston. Okay, in a real engine, it would be the crank or whatever is pushing down on that piston, but so that it gets to here. Now we're going to say the gas molecules are moving much faster. They've heated up. Does that have to happen? The answer is no, that doesn't have to happen. The temperature could stay the same. The temperature could go down. Why? Because when work is involved, okay, if there is work done, well, depending on this could either go up or down. So we're not going to memorize, we're going to understand each situation. But let's say in this case that our molecules are moving faster. Well, if our molecules are moving faster, that means delta U is bigger. Why? Because this gas has more energy. Why? Because the molecules are moving faster, okay? Well, if this happened, so going from there to there, work was done to the gas. And again, the wording is very important. So if work was done to the gas, that means we added energy to the gas, which means that the work was positive. And if this is positive and this is positive, if you look, that could be zero, that could be positive, it could be negative. It all depends on these other numbers. If you had 10 and 10, that's zero. If you had 10 and 8, that is positive 2. Does that make sense? If you had 10 and 12, this is negative 2. Does that make sense? Again, you're going to think about each situation and figure stuff out. But for this situation, we're going to pretend that, hey, you know what? That we compressed it, and let's say we started here. This was my A spot. And we're going to say, hey, I went to up here. No, actually, we'll say I went up there, because that's probably what would happen. The pressure would go up. We're going to say I went up to here. Well, if I go to this point, you would have to then use PV equals nRT, and you would see that in this case, the temperature got bigger, which means the volume decreased, but the pressure increased more. So this one up, and you could figure that out. How would you find the area? Well, sorry, how would you find the work? You would look at the area underneath that graph, and that would tell you the work done. And then you could figure out, did heat enter? Did heat exit? Depending on the value of this and this, like we just talked about. Okay? So there's that example. If it goes this way, so that if you look, okay, you can see this expanded. Well, if this expands, that means the gas did the work, because the gas pushed it this way and did the work to lift that up. Well, if the gas did the work, that means the gas is going to lose energy. And if the gas loses energy, hey, that means that there was negative work. We're going to say that the gas molecules are moving slower, so this is negative. Is that always going to happen? No, but you, again, could figure this out based on your PV diagram. And so let's say that this expands and this goes down to here. Okay, so it goes down to there, but P times V here is more than P times V here, so that it's moving slower, okay? And then the same thing, if this is negative and this is negative, this could be 0. If this was negative 10 and this was negative 10, then that would be 0. If this was negative 10 and this was negative 8, this would be negative 2, which means heat left our gas If this was negative 12 and this was negative 10, then this would has to be positive 2. So that means heat entered our gas. Okay, and it all depends. And to find the work, you'd find the area underneath the graph, and that's it. Okay, so hopefully that makes sense. Bye, kids.